A perfect conductor contains unlimited supply of free charges. Unlimited supply of free charges. Okay. So, in conductor, you have free charges. So they are responsible for conduction of electricity. So in that sense, I am writing a perfect conductor contains unlimited supply of free charges. Okay. Second point. Second point is related to the electric field. The electric field inside a conductor is always zero. So if you have a conductor, then the electric field inside a conductor is always zero. Okay. So like to give you an example, if I take this as a conductor, okay, and I put it in an external field E, एक external field E में रख दें तो क्या होगा? Positive charge will be pushed this side, free charges, and negative free charges will be pushed to the opposite side, right? And because of this, electric field will be created here, E, because of this. So if you see E net inside, because there are sufficient amount of free charges, so exactly equal and opposite field is created inside. So that's why the net field will become equal to zero. जबकि जब हम ये डाइलेक्ट्रिक मटेरियल लेंगे तो जितनी इलेक्ट्रिक फील्ड अप्लाई करेंगे उससे कम इलेक्ट्रिक फील्ड क्रिएट होगी. सो दैट्स व्हाई देयर विल बी नेट इलेक्ट्रिक फील्ड इनसाइड द डाइलेक्ट्रिक. सो right now we are discussing conductors. So in conductor, net electric field will be equal to zero. Okay. Is it okay? Clear? Now, third one is if you give a charge to a conductor, it will always come on the surface. So rho inside a conductor is always zero. Is always zero. Rho inside the conductor is always zero. So suppose you take a conductor like this, and if you give some charge Q to it, so the total charge will only come at the surface. No charge will remain in the bulk because inside the field is zero. So if you apply Gauss theorem, del dot E is equal to rho by epsilon naught, correct? Del dot E is equal to rho by epsilon naught. So since electric field is zero, so rho is also zero inside the conductor. Clear hai? Is it okay? So if you take 2 points inside the conductor, because electric field is zero, so potential difference between 2 points will also be equal to zero. So that means if you take 2 points inside the conductor, they will be at same potential. Okay? They will be at same potential. Okay. And if you see, this is the conductor. And if you see the electric field, suppose positive charge resides here. So electric field will be always perpendicular to the surface. The field will be always perpendicular to the surface, and parallel component of the field will be 0. Okay. Because the parallel component, if it is there, because of the charge will start moving. And without doing anything, current will be produced. So that will never happen. So like आपने देखा होगा शेल के लिए जब आपने कैलकुलेट किया था तो the field was always radial, which is perpendicular to the surface. Correct? ठीक है? So let us discuss little bit about induced charges. So suppose let us discuss little bit about induced charges. Okay. So if you take a sphere and suppose this is a conductor and you bring a positive charge Q near this conductor. So what will happen? Inside the conductor, the negative charge will try to come this side because of the attraction, and the positive charge will come this side. Okay. So this is the phenomena that is known as induction. इसको क्या कहते हैं? What we call it? Induction. Clear है?
सर सेकंड केस में भी इलेक्ट्रिक फील्ड जो प्रोड्यूस हो रही है इनसाइड वो भी इंड्यूस इलेक्ट्रिक फील्ड होती है ना?
Which case?
सेकंड
This?
केस हाँ, दिस इज आल्सो
This is
इंड्यूस्ड.
induced electric field. Induced electric field. Okay. So let us do a problem on this. Can I erase this? Note कर लिया सबने? Okay. So let us do a problem. Right? An uncharged spherical conductor centered at origin. So there is a sphere like this, which is uncharged spherical conductor. Okay. Centered at origin. So O will be here. And some shape, like any random shape, cavity has been created. Cavity. So this material has been taken out and a cavity is created. Cavity means empty space. Okay. And then you put a charge Q here. And you want to know what is the electric field at outside point P at a distance R from this sphere. This we want to calculate. Okay. So जैसे ये प्लस क्यू चार्ज आप यहां रखोगे, you will have a induced charge which is negative inside the surface, Yes. And because of this negative Q charge, positive Q charge will be created outside. This is induction. This is what is called induction. एक बार ध्यान से समझते जाना. So see, net charge in the conductor is 0. And you have put Q charge. So only Q charge is there in the system. Please understand this. So that's why on this surface, total negative Q charge will be developed. And on the outer surface, total plus Q charge will be developed. So total charge you add plus Q minus Q plus Q is equal to Q. So total charge is Q in the system. Because of the conservation of charge, right? And if I apply Gauss theorem here, suppose I just draw the Gaussian surface and apply the same small area and field concept. So what will happen? So closed integral E dot dA will give you Q enclosed over epsilon naught. So this will be E into 4 pi r square is equal to yes. What is Q enclosed? It is Q over epsilon naught. And E will become 1 upon 4 pi epsilon naught Q by R square into R cap. So this will be the electric field. All right. Boliye. Is it okay? So this is the electric field outside. Next question करें. If you change the shape of the cavity, what will be the effect on electric field?
No effect.
Nothing.
No effect.
No,
Nothing. Okay. Because you can see on what factor it is depending, right? चलो next question करते हैं. A metallic sphere. There is a metallic sphere of radius capital R. This is the center. A metallic sphere of radius capital R carrying charge Q is surrounded by a thick concentric metal shell. Of inner radius small a and outer radius small b. So
thick
this is
concentric क्या sir? Thick
shell.
concentric.
So it is like this. This is the shell. So this is the sphere and this is the shell. Thick shell. Thick shell means the inner radius is small a and the outer radius is small b. And this is where something is filled. And this is also solid metallic sphere. So this is also filled with metal. So metallic sphere is there, radius r, carrying charge q. So on this you have charge q. So you know charge will reside on the surface, right? No charge can be inside. So this is charge q, which is spread all over the surface. and shell has no net charge. Okay. So you have to calculate sigma R, sigma A, sigma B. Yes. What will be sigma R? Q by 4 pi R square. Yes. What will be sigma B? Sigma A. Sigma A कितना होगा?
minus q by 4 pi a square.
Minus Q by 4 pi A square. And sigma B
Plus q by 4 pi b square.
plus Q by 4 pi B square. So these are the charge densities. Yes. Is it okay?
Yes, sir.
So now calculate the potential at O. So first one will be because of the this 1 upon 4 pi epsilon naught Q. So Q by R, then minus Q by A,
A,
then plus Q by
b.
B. So this will be the potential. You can take Q outside. So it will become Q by 4 pi epsilon naught 1 by R minus 1 by A plus 1 by B. Okay. So now question C is outer surface has been grounded. Outer surface is grounded. So what will be the effect on the answers? So if the outer surface is grounded, this one is grounded, what will happen? You have to tell that. What will be sigma R? Then
It remains same.
what will be sigma A? What will be
Same.
sigma B?
The sigma b equal to 0.
Sigma R will become
As it is.
Q
Okay.
by 4
4
pi R
pi
is,
r square.
this will become minus Q by,
4 pi a square.
and this will be
0.
0. And what will happen on the potential? Potential V naught?
Q by 4 pi epsilon naught 1 by r plus 1.
Q by 4 pi epsilon naught 1 by R
Minus 1 by a.
minus 1 by A. This will become the potential.
सर प्लस 1 बाई ए नहीं होगा? प्लस 1 बाई ए होगा. सिग्मा i minus q by 4 pi a square है ना सर?
ठीक है भाई, क्या कह रहे हो? Right, next one. Can I raise? या इसमें किसी को डाउट है तो प्लीज कीप आस्किंग. क्लियर है ना? Please write next question. Two spherical cavities. So like you have a sphere like this, and you have two spherical cavities like this. This is small a, this is the center, and this is small b, this is the center. And here some QA charge is kept, and here some QB charge is kept. Okay. So two spherical cavities of radii A and B are hollowed out from a interior of a neutral conducting sphere of radius capital R. At the center of each cavity, a point charge is placed called QA and QB. So first question is get sigma A, sigma B, sigma R. Second question is E when R is greater than R. Third question is E inside cavity. And fourth question is force between A and B. These are the questions to be addressed. Okay, let us do this. So this is a sphere, conducting sphere, and cavities. This and this are the cavities. Let us do the first one. Sigma A will be
QA by 4 pi a square.
QA by 4 pi A square. Sigma B
QB by 4 pi a square.
Q cos 4 pi b square.
4 pi B
सर
square.
माइनस नहीं होगा, माइनस क्यू है, माइनस क्यू.
And minus here, minus here. Okay. And Q
QA is given now, so why minus?
sigma R. What will be sigma R?
QA
plus
QB
upon R
upon
square.
4 pi r.
QA plus QB by 4 pi R square. First of all, इसमें if there is any doubt, please ask.
सर माइनस साइन कैसे?
This
So इसको थोड़ा बड़ा बना लेते हैं. ये है, यहाँ QA रखा हुआ है.
हाँ जी
हेलो.
सर.
So here negative, 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 negative. Negative QA will be developed on the surface. I told you about the induced charges.
हाँ जी सर.
But charge is not on the surface. It is placed at the center. So how charge density will come on the surface? Charge density on the surface means charge by area. So this is the charge that will be spread on the surface. Clear hai?
ओके सर.
Is it clear?
yes, yes.
शिवानी?
हाँ जी सर.
तो यहाँ माइनस क्यों आ रहा है? Induced charge. Why minus is coming?
Induced charge.
Induced charge. Very good. So next question is, we have to get electric field outside the radius R. Let us get it. So when you write, when you take, suppose I take a Gaussian surface here at point P. So what will happen? E into 4 pi R square will become, what is the charge inside this Gaussian sphere?
QA plus QB.
QA plus QB. Please see, QA plus QB that is present on the surface. How much charge is present on the surface? QA plus QB. So if you add all the charges present inside this Gaussian surface, that will be QB minus QB. This will cancel. QA minus QA. This will also cancel. Only QA plus QB will remain. Everybody understanding? So E will be 1 upon 4 pi R square QA plus QB by 4 pi epsilon naught QA plus QB by R square. Please see this.
Sir,
Hmm.
on the surface of a cavity minus QA charge, that's why plus QA is induced, na?
So Q enclosed is QA minus QA plus QB minus QB plus QA plus QB. This is the total charge present inside the Gaussian surface. What are you asking?
Sir, एक minute, sir.
प्लीज चेक, सबको समझ आ रहा है?
Sir, on the surface of a cavity minus QA charge comes. And because of that, on the outer surface plus QA charge is induced.
So if you want to understand that, please see this. Suppose this is the cavity. So check the free surfaces, जो open surface होंगे. If you put a charge Q here on this whole surface, minus Q will be generated, right? And because of this minus surface, outside plus Q will be generated. This is the induced effect. So similarly here, because of this QA, QA will be generated. Because of this minus QA plus QA, because of this minus QB, again plus QB will be generated. So outer surface will have charge QA plus QB.
Sir.
Okay?
Hello, sir.
हाँ जी.
सर induced charge जो है केवल सरफेस पर है ना? मतलब
Only on the open surface. There no charge can reside in the bulk. Bulk में कोई charge नहीं रह सकता.
electric field 0 होगा अंदर inside surface.
वो भी सही बात है. चार्ज भी नहीं होगा, ये भी सही बात है. सब मैंने पॉइंट वाइज लिखवा दिया आपको.
Okay.
ठीक है? Is it okay? So can I erase this all? Now about the force. Force will be 0. Please write, because there is no electric field between them. So effect of one charge, अगर एक पहला चार्ज दूसरे के लिए इलेक्ट्रिक फील्ड क्रिएट कर पाता, then you would have force. So लिख लो F force between them will be 0.
That inside E is always 0.
Because you have something like this, na? So if this is kept in this electric field and this is kept in this electric field, then only possibility of force is there. But this is the bulk conductor here, field cannot survive. So field is 0 here. So that's why force between them is also 0. Okay?
Sir,
Hmm.
E is inside the conductor is 0.
Hmm.
But inside the cavity,
तो कैविटी, इस वाली कैविटी में इसका फील्ड कैसे आएगा? भाई फोर्स क्या होता है? Q into E.
yes sir.
तो अगर इसकी फील्ड यहां पहुंच जाए तो फोर्स लगेगा.
हाँ,
उसके रास्ते में बल्क है जहां पे फील्ड होगी नहीं. ठीक है?
0 है, yes sir.
तो गॉट दिस पॉइंट एवरीबॉडी?
सर इस टाइप का चार्ज में फ्लक्स लाइन कैसे ड्रॉ करेंगे?
Flux line will be from positive to negative charge. So like inside the cavity, you will have flux lines emerging from plus Q and going towards the negative charge. I mean the surface.
अच्छा, ठीक है सर.
So now
Sir,
a big part of your topics is finished and we have to move towards the advanced part. हाँ बोलो भाई.
सर माइनस क्यू ए चार्ज सर कैविटी के सरफेस पे तो प्रोड्यूस होगा ना सर,
हम्म.
और माइनस क्यू भी दूसरे कैविटी के है.
अंदर
यस
जैसे
सर,
ये
अंदर
कैविटी
में.
है, इस साइड तो बल्क है ना, इस साइड
यस
बल्क
सर.
है, इस साइड फ्री सरफेस नहीं है, ये फ्री है. So if you put Q here, then this is minus Q.
माइनस क्यू. तो सर अगर कोई और स्फीयर है जिसमें माइनस क्यू चार्ज सरफेस पे है तो इन दोनों के कारण फील्ड डेवलप होगा कि नहीं?
अगर दूसरा, if another one is in bulk,
यस सर.
तो यहाँ पे तो बल्क है ना.
ओ ओके सर, ओके सर.
Sir, electric field inside the cavity?
Is finite. If you calculate, if you take this much and put it like this, then 1/4 pi epsilon naught Q by R square.
यस सर.
We have done it in first question. पहले क्वेश्चन में यही तो किया है.
यस सर, यस सर. कर
हाँ जी
लीजिए
भाई.
सर.
नहीं, जो पूछ रहा है पहले उसको क्लियर करने दिया करो.
Yes, sir.
परमप्रीत.
Clear. Clear,
So
sir.
if you take a small distance, small r, and make a Gaussian surface, so Q charge will be inside the Gaussian surface, right?
Okay, sir.
So electric field will be 1/4 pi epsilon naught Q by R square. Fine?
Sir,
Hmm.
sir, if two concentric spheres are in the inside area is around the bulk, then E is always 0.
Inside the bulk.
दो स्फीयर यदि आपस में मिल रहे हैं तो जो उनका उतना रीजन बच रहा है वो बल्क में है, तो उस रीजन में E 0 ही होगा.
तो वो कैविटी की बात कर रहे हो?
नहीं सर, कैविटी की बात नहीं कर रहा.
हम्म.
दो स्फीयर हैं,
हम्म.
एक दूसरे पे ओवरलैप कर रहे हैं.
हम्म.
ओवरलैपिंग वाला हिस्सा है ये. यदि
कैसे स्फेयर है? कंडक्टिंग.
यस सर, कंडक्टिंग स्फीयर.
कंडक्टिंग में तो वैसे भी 0 होगा, वैसे भी 0 होगा. व्हाट इज द पर्पस ऑफ ओवरलैप?
और मेटेलिक में
मेटेलिक कंडक्टिंग आर सेम थिंग. ऐसा क्वेश्चन डाइलेक्ट्रिक वाले में है
जी सर.
जिसमें मैंने आपको और ट्रायंगल लॉ से बताया था कि यहाँ पे फील्ड जो होती है दैट बिकम्स अ कांस्टेंट, राइट? चलो अब हम लोग we have already discussed Poisson equation and Laplace equation, right? So under special techniques, to calculate potential. So ultimate goal will be now to calculate the potential, right? So some ways you learn, now more ways you have to learn to calculate the electric potential. To calculate electric potential. Is it fine? So what is the Poisson equation? Del square phi is equal to minus rho by epsilon naught. We have done this. And what is Laplace equation? It is del square phi is equal to 0. Correct? These are the equations. कल मैंने
Yes.
electrostat का I gave you summary. Please see that.
Yes.
This is called Poisson equation. Poisson equation. And this is called Laplace equation. So when the region is charge free, then you have Laplace equation. So if I write the Laplace equation in one dimension, please see this. Del 2 phi by del x2 is equal to 0. How to get the solution? So integrate it once. You will get del phi by del x is equal to c. Integrate it one more times. So you will get phi is equal to cx plus k. So this is your solution of one-dimensional Laplace equation. Right? So this will be a straight line. Maybe in some case it goes like this. This is the potential versus x graph. If this is k and c is negative, the slope is negative. So this will be the Laplace equation solution in one dimension. So because it is a second order differential equation, two constants appear. So you need two boundary conditions. Two boundary conditions to completely solve it. To completely solve it. Okay. So the techniques we are going to learn is to get the electric potential. जैसे भी calculate करो, we have to get the electric potential. Okay. So there are very, very important properties related to this. Which is like, if you want to calculate the potential at this point, you just take the average of the potentials in the neighborhood. That will give you the potential at this point. So potential at this point will be the average of potentials at these points. Okay. So if I take this potential as a potential at this point, a plus epsilon point, and potential at a minus epsilon point. So potential at a will be equal to half of potential at a plus epsilon plus potential at a minus epsilon. Okay. So that means it is a smooth, well-behaved function. The potential is well-behaved. ऐसा नहीं है कि अचानक ही कहीं पोटेंशियल बढ़ जाएगा. So if you want to get it at a point and you know in the neighborhood, so take the average, you will get the potential. And second point is no local maxima or minima. No local maxima or minima. So that means it will not be have suddenly something like this or something like this in the potential. Not suddenly, but gradually. Okay. So now let us 1D तो कुछ ज्यादा ही आसान है. Let us try to solve it in 2-dimension and Cartesian coordinate system. So the first technique to calculate the potential you are learning. So you are learning the techniques to calculate the electric potential. So the first technique that you are learning is solution of Laplace equation that will give you the potential. The solution of Laplace equation will give you the potential. Okay. So what is the Laplace equation in 2-dimension? Del 2 phi by del x2 plus del 2 phi by del y2 is equal to 0. Okay. This is the electric potential in 2-dimension. 2D. So when we solve this, we need 4 boundary conditions. You can see how many boundary conditions are needed to solve this. You need 4 boundary conditions. So when you solve this, then you get phi x comma y is equal to some c1 e to the power lambda x plus c2 e to the power minus lambda x and multiplied by a cos lambda y plus b sin lambda y. When we will discuss partial differential equation, I will teach you variable separable technique. Variable separable technique to handle it. Right now, you just take this and जब हम सवाल लगाएंगे तो हम इसके आगे करेंगे. ठीक है. जो मैं एवरेज वाली बात बता रहा था कि जैसे किसी पॉइंट पे निकालना है पोटेंशियल, तो तुम उसके अबाउट मान लो 2-डायमेंशनल है तो इस तरीके से सर्कल लेके हर पॉइंट पे पोटेंशियल लिखो और एवरेज निकाल लो. और अगर 3D है तो हर पॉइंट पे पोटेंशियल लिखो और पूरे सरफेस के हर पॉइंट पे लिखो और एरिया से डिवाइड कर लो. तो इस केस में क्या हो जाएगा? 5 विल बिकम 1/2πr. देखना ध्यान से. क्लोज्ड इंटीग्रल phi dl. And in this case, what it will become? Phi is equal to, can you tell? Here it is 2πr. Here the area will be 4πr square. Integral phi dA. So this is what, if you want a potential at a point, you can get the average. ये पीछे नोट कर लेना जहां पे मैं एवरेज वाली बात कर रहा था. Note down there. Okay. तो अब जरा एक क्वेश्चन करते हैं इस पे. Suppose a 2-dimensional region is given like this. This is 2D. This is x-axis. This is y-axis. This is the region. This is 0, 0. This is a, 0. This is a, B. This is 0, B. Here potential is 0. Here potential is 0. Here potential is 0. And here potential is some constant potential phi naught. This is the problem. ध्यान से देखना. This is the region. In this region, I want potential at any point x comma y, or let me represent it by phi x comma y, any point where x will be going from 0 to a and y will be going from 0 to b. So first of all, understand the question, then we will discuss. This is the region, this shaded region. So you have to get this in shaded region. Shaded region. चेक करो, ये समझ आ रहा है सबको? तो एक रीजन है, उसमें नीचे वाले लाइन पे पोटेंशियल 0 है, यहां 0 है, यहां 0 है और यहां 0 है. और इस रीजन में चार्ज कितना है बताओ भाई? दिस इज चार्ज फ्री रीजन. कैसा रीजन है? चार्ज फ्री. तो पोटेंशियल सिर्फ इसकी वजह से, जो सोर्स है ना, कोई पोटेंशियल गिवन है ना फाई नॉट, द पोटेंशियल इन द रीजन इज ओनली बिकॉज ऑफ दिस, otherwise it is a charge free region. So for charge free region we can apply Laplace equation, yes or no? बोलिए भाई.
Yes, sir.
Because it is charge free region, I can apply Laplace equation. That means del 2 phi by del x2 plus del 2 phi by del y2 is equal to 0. Is it correct? Now the solution of this equation, I told you phi xy is very, very symmetric. It is c1 e to the power lambda x plus c2 e to the power minus lambda x into a cos lambda y plus b sin lambda y. This is phi xy. So I can write phi of xy as only function of x and only function of y. This is only function of x and this is only function of y. So actually इसी तरह से इसको derive करते हैं. तो ये सारे, these all are boundary conditions that are given 1 2 3 4 and they will remove all the constants from it. Okay, so let us apply the first one. Let us first of all write the boundary condition. This whole line is what? Tell me.
Y equals to 0.
Y equal to
Y.
0.
So this whole line is y is equal to 0. So if you write y of, please see this, phi of x comma 0, that is 0. This is the first boundary condition. अगर y की वैल्यू 0 है तो पोटेंशियल 0 है. इसको ओपन करके लिखते हैं, x and y0 is 0. So दो चीजों का प्रोडक्ट 0 है, that means y0 is equal to 0. So this is the first boundary condition. Let us apply this one, this line. Phi of 0 comma y is also 0. क्योंकि इस पूरे लाइन पे x की वैल्यू 0 है. On the y axis x is equal to 0. So it will become x0 y is 0. So this implies x0 is equal to 0. Third one. What is this line? This
Zero
line
y
is
y
y
equal to
equal to 0.
x comma b. This is 0. ऊपर वाली लाइन पे हमेशा y की वैल्यू क्या है? b है. So this will be xx and yb is 0. So that implies y of b is equal to 0. This is the third condition. So we will apply these three. Fourth, we will apply finally. To understand this, ask how I have written the boundary conditions. कैसे लिखी गई हैं? फटाफट पूछो. So ये पूरी एक्सिस है y is equal to 0 और ये पूरी एक्सिस है x is equal to 0. ये पूरी एक्सिस है y is equal to b और ये पूरी एक्सिस है x is equal to a. पूछना भाई अगर कोई डाउट है तो. तो अब एक एक करके अप्लाई करते हैं. पहले y वाला, x वाला, y वाला. So let us apply first of all the x1. x0 is 0. What is xx? It is c1 e to the power lambda x plus c2 e to the power minus lambda x. So x0 will become c1 plus c2 is equal to 0. So that means c2 is equal to minus c1. Apply kar do. So xx will become c1 common e to the power lambda x minus e to the power minus lambda x, which is equal to c1 sine hyperbolic lambda x. Is it okay? Now let us apply boundary conditions in y. y is a cos lambda y plus b sine lambda y. And the first one is y0 is 0. So a cos lambda 0 plus b sine lambda 0 is 0. So which implies a is equal to 0. So that means y is just b sine lambda y. So this is the first boundary condition I have applied. Now second one is yb is also 0. So b sine lambda b is also equal to 0. So that means sine lambda b is equal to 0, which can be written as sine n pi. That means lambda is equal to n pi by b. Lambda is equal to n pi by b. So we got x and we got y also, in which lambda is n pi by b. Is it okay? Now it's time to write the solution. अब देखो जरा ध्यान से, ये मिटा दे रहा हूं. These we have used already. Now our solution is phi x comma y is equal to. Now please understand, यहाँ पे lambda की जगह n pi by b आ जाएगा दोनों में, and n is satisfied for 0, 1, 2 dash dash dash. So that means सारे n को हमें लेना पड़ेगा. So that means मैं sum लिख दूं, n is equal to 0 to infinity, and then this b will be multiplied with c and it will give a new constant. So I will write kn as new constant, and then I will write sine hyperbolic lambda, which is n pi x by b into, there you have sine lambda y, so it will be sine n pi by b into y. So this is the solution that you got. समझ आ रहा है? I have substituted the value of lambda. तो फाइनली हमको ये यूज करना होगा. जस्ट अगर सिर्फ एक जगह यहाँ पे बदलता जाएगा, बाउंड्री कंडीशन, नए नए बाउंड्री कंडीशन दिए जा सकते हैं, एंड वी शुड नो दिस इन दिस रीजन.
सर कांस्टेंट, ये kn कांस्टेंट का क्या है?
भाई तुम देखो, x और y मल्टीप्लाई करोगे ना,
यस
तो
सर.
c1 और b दोनों मल्टीप्लाई होगा, तो एक नया कांस्टेंट बन जाएगा, उसको k लिख दे.
यस.
Suffix n is because large number of n values will satisfy this, na? Sin lambda b is equal to n pi. So n pi will be 0 pi, 1 pi, 2 pi, 3 pi, all values will be satisfied. So that's why I have put suffix kn. And n can be any value from 0 to infinity. So linear combination of all will be satisfied to give the potential. ये बहुत ही अच्छे क्वालिटी की मैथमेटिक्स है, आप ध्यान से देखो, you will enjoy. तो यहां तक देखो, क्लियर है सबको? तो इसके आगे का हम लोग अगली क्लास में करेंगे. इफ यू हैव एनी डाउट प्लीज आस्क अप टू दिस.
Sir, according to the n, the angle will vary, na? But how the constant depends upon n? We are writing subscript. So,
ये देखो, तो लैम्डा b इज इक्वल टू n पाई है ना,
so b is
तो
equal to
लैम्डा विल डिपेंड ऑन n, so
yes.
its coefficient will also depend on different values, it will also change. So
Yes,
that's why I have put n on the coefficient. Okay,
okay, sir, clear.
चलो, okay, thank you.
Thank you, sir.
क्यों सर?
Thank you. अच्छे से रिवाइज करना, फिर नेक्स्ट क्लास में डिस्कस करेंगे. ओके,
Yes, sir.
ओके, थैंक यू.